Well, hello everyone. Today we're going to look at first section in, I believe, chapter 3. We're going to be looking at finding the equation of a line. And there are different types of information that you can be given, and each one requires a different approach to how you calculate the equation of a line. The lines that we're talking about are essentially, linear equations, obviously. Y equals 2x plus 3, that type of look. And we're going to find a couple of examples where you're going to be told the slope and the coordinates of the y-intercept. And that's questions like number 2 and 8. Big chunk of questions where you're going to be given the slope of the line and the coordinates of some single point P. A lot of questions, probably just about as many as this type, where all you're going to be told are the coordinates of 2 points that are on the line P and Q. Then a couple of special cases. How do you find the equation of a line when the slope is undefined? That essentially means when it's like that pen, right? When it's vertical. And lastly, a couple of application questions. So I'm going to jump right into the first type, which is how do you find the equation of a line when you know the slope and the y-intercept? So we typically use the letter m to represent the slope. So let's suppose the slope is 3. And the y-intercept can be given in a number of ways. You could simply be told in this format that the y-intercept is 5, or you could be told that the y-intercept has coordinates 0, 5. They're totally equivalent. And so what's the equation of a line with a given slope and a given y-intercept? The equation of it is y equals mx plus b. So that's the equation we're going to use to generate the equation of a line. It's where m is the slope of the line. And where b is this guy here, right, the y-intercept. So that's probably the simplest equation of a line you can get. It's simply y equals so many x, like 2x plus a number like plus 5. So in this example here, y will be equal to 3x, and the intercept, the y-intercept is 5. And there's your answer. Suppose they ask you to find the equation of a line where the slope is 5 and the y-intercept is given as 0, negative 3. Well, y equals the slope x plus the intercept. 5x add negative 3 is essentially that guy, and you're finished. And that's how you find the equation of a line when you're given the slope, m equals, and the y-intercept, either as a value or as a coordinate. It's essentially taking care of those questions. Now, how do you find the equation of a line when you're told the slope, but not the y-intercept, but just a general point on the line? So, can you imagine that you're given a line? And maybe it's this line here. And you're told that this point here has coordinates 3, 8. And that you're also told that the slope is 2. So that's pretty standard question. So you'll be given, find the equation of a line where m equals 2, the slope is 2, and it passes through a point, in this case, 3, 8. Well, we have an adaptation of this equation. It's a little bit trickier. The formula looks like this. Y take away y1 equals m brackets x take away x1. So it's a little bit messier formula. And this will eventually get us the equation of the line that I've got up there. So let's tell you who we are. Where m, not surprising, is the slope of the line. And this x1, y1, that's essentially who the point P is. P has coordinates x1, y1. And so that will be the coordinates of a point on the line. So let's take our question again. The slope is 2 and the point is 3, 8. I'm going to call that guy x1. I'm going to call that guy y1. So it's going to be y take away y1 equals m x take away x1. That equation, by the way, is called the point slope equation, if you're interested in its name. It's now y take away 8 is equal to 2 x take away 3. Now, you don't leave the answer looking like that. We want the equation to be typically in the form y equals. So what I'm now going to do is distribute the 2. So I have 2x, and 2 times that is -6. Then I'm going to add 8 to both sides. And this is the equation of the line. Y equals 2x plus 3, and we're done. So let's pick a couple examples of questions like that. This, for instance, is a version of question 4, where the slope of the line happens to be a half, and the point that we are told it passes through is 8, 6. So y take away y1 is m brackets x take away x1. And this guy is x1, and this guy is y1. So we have y take away 6 is 1/2 x take away 8. Distribute the half, we get 1/2 x take away 4. Add 6 to both sides. And there is the equation of your line. Let's try something with uglier values. This is a version of question 6, where we're told the slope is -5/3 and that the point that it passes through is 3, 0. I'm going to call this guy x1 and this guy y1. I'll begin by writing down the general point slope equation. In this case, y take away 0 is going to be -5/3 x take away 3. That simply gives you y. Distribute the -5/3. You get -5/3 x. And this guy times this guy gets you +5. And we now have the equation of the line in the y equals form. And we are done. And that is the process that you use to find the equation of a line when you're given the slope and a point that the line passes through. And that's that done. So let's look at the next group of questions, which start at, I believe, 16. And we're being asked to find the equation of a line when you pass through 2 points. So let's call the first point x1, y1. And let's call the second point, I'll call them p's, because that's what the textbook likes to call them, round q's, which is that guy. So can you imagine what that might look like? Can you imagine there's a point, this is the line, and there's a point here, P1, And up here, there's the second point P2, and you can imagine that there would be a line passing through them, and it looked maybe something like that. Now, what we're going to do here is an extra step. We are still going to use this equation, the point slope equation. The difference is that we first have to find out what the slope of that line is, so that we'll know what the value of m is. And then we can choose either one of these 2 points to be this guy. And it doesn't matter which one of these 2 points that you use, you end up when you're finished with the exact same answer. So it's kind of go that way. Well, let's find the slope joining 2 points. The slope of a line is called m, and it's basically the rise. Measure a dotted line. This and this. It's this distance here, which is called the rise, divided by this distance here, which is called the run. So I have a rise over the run. We typically calculate it like this. The rise is y2 take away y1. And the run is the difference in the x coordinate. So it's going to be x2 take away x1. And that guy is going to be the first step, because once we know the slope is, and we've got one or other points for p, we can then use the point slope equation that we used in the other earlier questions to get the equation of the line. Okay, so let's choose say a version of the question. Let's choose 17. We want to find the equation of the line passing through the point 0, 2 and passing through the point 3, 5. So I'm going to call this guy x1, y1. I'm going to call this guy x2, y2. I'm going to get the slope now using this formula. Rise divided by the run. And you got to be a little bit careful, especially if there's any negatives floating around. In this case, there isn't, but the next question I'll make sure there is. 5 take away 2 on the top, 3 take away 0 on the bottom. 3 divided by 3 is 1. Also, I now know the slope. So our question really becomes, find the equation of a line whose slope is 1 and who passes through the point 0, 2. Or 3, 5, if you felt like it, you get the same answer. I can now use the point slope equation. There x1, there is y1. So that guy take away 2 is 1 times x take away 0. So y take away 2 is 1 times x, which is x, and 1 times 0 doesn't matter because it's still 0. And then you add 2 to both sides. And there's the equation of the line. Let's do one with a lot of negatives. So I want to find the equation of a line passing through the point 3, negative 4 and negative 5, negative 2. So I'm really making these as ugly as I can. Hopefully something nice will come out of it. To get the slope, it's y2 take away y1 over x2 take away x1. So here's x1 and y1. Here are the values for x2 and y2. So it's going to be negative 2 take away negative 4. And on the bottom, negative 5 take away 3. Well, that's -2 add 4. And that guy, take away that guy, is -8. And these two combined give me +2 over -8. And so I get, once we simplify it down, that the slope is -1/4. I'm now going to use the point slope equation to get the equation of the line. Use this guy for x1 and y1. So y take away -4 is equal to -1/4 x take away 3. That becomes y plus 4, and you distribute the -1/4. And you get that. Now what I should do next, and I'm going to do that, is I'm going to subtract 4 from both sides. So essentially I'm going to have to take 3/4 and subtract 4 from it. And I don't want to go decimals or rounding off or anything like that. I want to get an exact fractional answer. So here we go. 3/4. Take away 4. That's the answer as a decimal. I'm then going to go math, choice number 1, enter. And I get -13/4. And that is the equation of our line. -1/4 x, -13/4. Not the prettiest answer in the world, but it is the answer. Let's try one last one of that type. And this time I'm choosing one with a lot of zeros in it. So this is similar to question 20. And 0, -2. And the other point is 4, 0. Let's label everything. x1, y1 for the first point, x2, y2 for the second point. To find the slope, it's the difference y2 take away y1, it's essentially the rise, divided by the distance x1, x2, so you subtract them. And that's the rise, that's the run. In this case, what do we get? We get a 0, take away a -2, and on the bottom, we get a 4, take away a 0. And 0 take away -2 is 0 add 2, 4 take away nothing is 4, and 2 over 4 gets me eventually 1/2. So I now know the slope. I'll use the point slope equation to now get the equation of the line. It's going to be y take away that number equals 1/2 x take away that number. So that's going to be y add 2, distribute the half times nothing is nothing, and then subtract 2 from both sides. And we are finished. We now know how to find the equation of a line if you are given the coordinates of 2 points. And that essentially takes care of that one. We've already done that one. So let's backtrack a little bit and do some special cases. That's this one. What do you do when you've been asked to find the equation of a line and you're told the slope is undefined? Right? An example of that would be question 12, I believe. So imagine that I want to find the equation of the line passing through that point and the slope is undefined. You can't really use the equations that we've got because we need to know a number for the slope, like a half or -20. You can't put the word undefined in an equation. It really doesn't make sense. It doesn't do anything. So we're going to approach this in its own unique way. I do know something that's very important. I know that a slope is undefined means that it's vertical. So I'm just going to plot roughly where the point 4, -2 is. It's there. And I know that that has to be vertical because its slope is undefined. And if you do a vertical line where all the coordinates, including this one, have an x coordinate of 4, you now have the equation of the line. It's all the points whose x coordinate is 4. So in a way, it's a lot quicker to do, isn't it? Let's try another one. Suppose I have the point 3, I'll make it -3, 4. And the slope again is undefined. So this is a special case. So I'm essentially finding the equation of a line that passes through this point who is vertical. Undefined means vertical. Right, so I'll try and do a very basic sketch of this guy, just to visualize it. There is the point P. And we have a line that is undefined passing through that point. That's a vertical line. What are the x coordinates of that point? Its x coordinate is 3, or I should say -3. And there is your equation of your line. By the way, that's the equation of the line in that case. So it's a special case, right? If the line is vertical, you do that. Now, they could be sneaky with you. Watch what happens. Suppose I gave you a question where I asked you to find the equation of a line passing through those 2 points. Nothing too remarkable about that question. It's like a lot of others, but at least it looks a lot like. Let's see what the slope looks like. y2 take away y1, x2 take away x1, 5 take away 7, 3 take away 3, and then we get that. Now, if it was 0 on the top and 2 on the bottom, the answer would just be the slope was 0, and we could deal with that. We could use a formula. But it's not. It's -2 on the top divided by 0. Anytime you have a fraction where 0 is in the bottom, you're going to consider that as being undefined. So what we've really got is a vertical line. And can you imagine 1, 2, 3? Can you imagine 3, 7 is here, 3, 5 or whatever is here? What you've really got is just a vertical line. And what's the common thing about them? A vertical line that's passing through an x equals 3 situation, right? So the x coordinates are always going to be 3. So the equation is x equals 3. And we are done for that. Well, let's move on to applications. And there's just 2 of them. Let's get them. I'll try and show them on the screen. Okay, let's go over and look at the questions first. Then we'll worry about their solutions later. Okay, first one. A jogger is running at 8 miles per hour. So I better start writing some of this down. He's running at 8 miles per hour. And he burns approximately 13 calories a minute. Okay, find the linear function for the number of calories burned by that jogger in terms of the number of minutes run. And we're given f of x equals. So let me So what we're going to do is we're going to take this information and use the numbers that they're given and see if we can come up with a formula, f of x, where x is the number of minutes, and we're trying to figure out exactly how much that particular person burns. The red herring here is that guy, because I'm only interested in f of x, and f of x is how many calories burned in x minutes. I already know that you burn 13 calories in a minute, and I'm pretty sure I haven't skipped over to the right thing. I haven't, so let me start again. You're told that they run 8 miles an hour. You're also told that this person burns 13 calories per minute. That piece of information is not useful. You could have told me his name was John and he burned 13 calories per minute. You could tell me he is a Scotsman and he burned 13 calories per minute. You could even tell me his birthday and he burns 13 calories per minute. But the only thing that matters is that he burns 13 calories per minute. So if you want to know how many calories he burns in X minutes, you could argue like this. In 1 minute, he burns 13. In 2 minutes, he burns 13 times 2. In 20 minutes, he burns 13 times 20. In X minutes, he will burn 13 times X. So the answer to the first question, which is find the formula for the number of calories burned in X minutes, and the answer is simply just 3x. And that's question A. And question B then says, okay, suppose he goes out jogging for 37 minutes. How many calories does he burn? That still doesn't matter. This matters. The amount that he uses up or burns in 37 minutes is the value of this function when x is 37. And that ends up being 481. You can check on the calculator. And we're finished. So I guess the moral of this story is just because you're told something doesn't mean necessarily that that piece of information is useful or even going to be used. We've got one more to do. Let's do a version of question 25. And I'll just read out the story. I'll draw a little picture. A plane takes off from an airport, which is already 5,200 feet above sea level. So if you can imagine, there's ground and his airport is here. There's my aircraft. He is already 5,200 feet above sea level. Right? And we're told that he climbs to a height of 30,000 feet above sea level. And he does it at a constant rate of 900 feet per minute. So can you imagine the aircraft takes off and it goes on like that, and he climbs to a height of 30,000 feet. And can we pretend this is sea level here? And we know that the rate he increases is at 900 feet per minute. So we're going to put all of this together And it says in the question, find a linear function, f of x, that will tell you the height of the plane x minutes after takeoff. Well, if I'm going to find the height of the plane, it's going to be starting at 5,200 plus whatever the extra is after, what's that? Let's call it x minutes. Well, it starts at 5,200. That's the guy that's going to tell me every minute it's another 900. After 1 minute, he's climbed 900 feet from the start. 1,800, 2,700. So after X minutes, I guess I could put it in here, after X minutes, he's here. There's the equation. If you want to know how high that aircraft is after 10 minutes, you just plug 10 in here and do the calculation. If you want to, after 3 minutes, plug 3 in here for X and do the calculation. And that's part A. Part B says, what will its height be 9 minutes after takeoff? So I just have to find the value of my function when X is 9. So that's 5,200 plus 900 times, by coincidence, 9. And that ends up being, check on your calculator, 13,300 feet. So let's go back to that question. But they told us he climbed to 30,000 feet. Surely I should be using that number in some way. Well, actually, no. All I really needed to know was this number and what height he started off at. That's all I needed. The fact he climbs to 30,000 feet or 50,000 feet in this particular question was irrelevant. So it's another one of those, just because they tell you something doesn't mean that you need to use it. Are we good? I hope. And that is a good place for us to finish.